Dear students, now I'm explaining about what is electrolysis. State the Faraday's first law of electrolysis. Okay, this question is also very important 8 marks question for board examination point of view. Here we need to write the definition of electrolysis and need to write statement and mathematical formula of Faraday first law. Look here. The decomposition of electrolytes into constituent elements under the influence of applied electricity is called electrolysis. That is the definition. Here for easy understanding, all of you look here. This is a electrolytic cell. That electrolytic cell contains potassium chloride as a electrolyte, and which contains anode and a cathode. Through the anode cathode, electricity may applied. The potassium chloride solution is decomposed here into its constituent elements. At anode, chlorine liberated. At cathode, potassium deposited. That's why statement is very simple. The decomposition of electrolytes into its constituent elements under the influence of applied electricity is called as what? Electrolysis. Here, chlorine liberated by the oxidation, potassium deposited by the reduction. Here this phenomenon is what? Electrolysis. Now Faraday's first law. Here very simple definition from the mathematical expression. M is mass, Q is what? Electricity. Okay, that's why the amount of substance deposited at electrodes during in the electrolysis is directly proportional to the quantity of electricity. That means very simple. Directly proportionation means when charge of electricity is increases, the deposited amount of the substance also increases. If decreases, their mass also decreases. Okay, that's why the mass of the substance deposited at electrode during an electrolysis is directly proportional to charge applied in the electrolysis. Okay, that's why M directly proportional to Q. This proportionation is converted into constant. Here the constant will come. M is equals to EQ. Here capital E is what? Here electrochemical constant. Then Q is equals to charge under time. Here it's a product. That's why M is equals to ECT. Here when we insert the charge of electrons, denominator N will come, and introduced Faraday constant, that is capital F. So equation is M is equals to ECT by NF. Here capital F is called Faraday. 1 Faraday is equals to 96,500 coulombs. Along with electrolysis Faraday first law, this problem will also ask. Okay, look at here. A solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 amperes. What is the mass of copper deposited at cathode? Okay, here Faraday first law equation only used for solving the problem. Look here, what asked here? Mass of the copper. Mass of the copper is asked. Here 1.5 amperes, that is what current given. Here 10 minutes time given. Here as per SI units, minutes converts into seconds. That's why 10 into 60, 600 seconds. Okay, N is what? Charged during in the electrolysis. Copper sulfate dissociated, which gives what? Cu plus 2 and SO4 minus 2. The transfer of electrons are 2. That's why the number of electrons are 2. Here E is what actually here equivalent weight. Equivalent weight means what copper atomic weight by their charge. That's why already charge given here. All the values are substituted. We get 63.5 into 1.5 into 600 divided by 2 into 96,500. After the solving, we get 0.93 grams of the mass of the copper. Okay, dear students, now I am explaining another important question. That question is, state and explain kohlrausch law of independent migration of ions and give its application. This question also important question for board examination point of view. Look here, very simple answer now I am giving. Look here, the equivalent conductance at infinity dilution of an electrolyte is equal to the sum of the mobilities of the cation and anion is called kohlrausch law. Very simple from the mathematical equation. This cap is what? Equivalent conductance at infinity dilution of an electrolyte is equal to the sum of the mobilities of cation and anion is called as what? Kohlrausch law. Very simple. Once again I will repeat for you. The equivalent conductance of a electrolyte at infinity dilution is equal to the sum of the mobilities of cation and anion is called as Kohlrausch law. Okay, very simple answer. Now its applications. It is used to calculate the equivalent conductance of weak electrolytes. It is used to calculate the equivalent conductance of a weak electrolyte. Here example now I am giving. Here equivalent conductance of acetic acid is calculated by sum of the equivalent conductance of sodium acetate and hydrochloric acid. Then it is subtracted by equivalent conductance of sodium chloride. Now look here, after the dissociation, the equivalent conductance gives mobilities of acetate ion, mobility of sodium ion. From hydrochloric acid, mobility of H plus ion, mobility of chloride ion. From the sodium chloride, mobility of sodium ion, mobility of chloride ion. Now we are here on sum. Here the same values plus or minus are cancels. That's why we get cap infinity of acetic acid is equals to lambda of acetate ion plus lambda of H plus ion. Here this is what one application of Kohlrausch law. Here we are solving the equivalent conductance of acetic acid by the another reactant of the reaction. Okay, next second application, it is used to calculate dissociation constant. This Kohlrausch law is used to calculate dissociation constant of an electrolyte. Here that dissociation constant is expressed by alpha, that is equals to lambda V by lambda infinity. Here lambda here what? Conductance at volume V. Here conductance at infinity, their ratios. Here that is equals to dissociation constant. Next, it is used to calculating the solubility of Sprangli soluble salt. Here solubility is S. S is equals to here specific conductivity into 1000 by cap infinity. Here cap is what? Equivalent conductance at infinity. Okay, this question is what kohlrausch law and its application. Okay, thank you. Here now I am explaining another important 8 marks question from electrochemistry lesson. That question is, what are galvanic cell? Explain the working of a galvanic cell with a need sketch taking Daniel cell as example. Here we need to define galvanic cell and the example, diagram and working explanation. Okay, now galvanic cell. Galvanic cell is a device which converts the chemical energy into electrical energy, is called galvanic cell. Here actually it is a device, the device which helps conversion of chemical energy into electrical energy is called galvanic cell. Example of galvanic cell is what? Daniel cell. Okay, we need to here draw it diagrams. Okay, from the diagram now I am explaining. Here this cell contains two equal half cells. How many half cells? Two equal half cells. Here left hand side of the cell contains zinc rod which is present in the aqua zinc sulfate solution, and this zinc rod act as anode itself. Then right hand side of the cell contains copper rod which is present in the aqueous copper sulfate solution, which is act as a cathode itself. Okay, understood? Left hand side zinc rod, anode which is present in the aqua zinc sulfate. Right hand side copper rod, it is act as a cathode which is present in the aqueous copper sulfate solution. Now both the solutions are connected through the salt bridge, and the both metallic rods are connected by the metallic wires. From the arrangement, the following reactions takes place. Such reactions of chemical energy is converted into the electrical energy. Now the reactions are what? At anode, zinc undergoing oxidation and produces Zn+2. Here at cathode, copper ion is undergoes reduction and forms a copper. Here when we write the overall reaction, here electrons are cancelled. Now the reactants are Zn Cu+2 and products are what? Zn+2 and Cu. Here what happened? Electrons are transferred from anode to cathode. Mobility of electron takes place is nothing but what? Chemical energy is converted into electrical energy. Okay, this is about what galvanic cell and its construction. Okay, thank you.